Okay, so we're up and running. We're using the audio through my computer, which is not perfect, but that's okay. And we had a request. So I guess the request, which I'm sympathetic with, is to go through Jim's examples to make sure we sort of follow along what the and so I'm going to go through and do these 9 exercises together with other folks, and then perhaps embarrass myself, but I'm old enough that I don't care. So give it a shot. Maybe
I think you're going to find these incredibly easy.
So I just have to go now to my Skype, and then I can download them.
And everyone, you can get them on the WinDC website under Monday.
And also I sent the link. So 12:23. That's the link for Monday, and it is GAMS exercises.
Yeah, so if I say download, accept.
And we could also just
Extract.
put it on here, I guess.
So I'm going to say, where did that extract all? There we go. And I'm just going to go grab. Okay, so now if I look at what I've got, there are the exercises. So we'll start with Q1.
Yes.
Okay, I also sent it to everyone on the chat. You just need to extract it like Tom just did to be able to open them in GAMS.
Yeah, so I've got whatever, a total of 8 exercises. We just do these one at a time.
Yep. They're all pretty.
And so this is saying alpha. So let's make some 4.5 is this number. P is going to be equal to 2.
Mm-hmm.
This guy is equal to 1. I'm just moving that around. I don't
That's all right. Yeah.
The assignment. And now he gives us the variables. So I'm going to say, and the equation will be first order conditions. These equations I have. So I'm just going to copy these guys down. Dot, dot. And then the other equations we've got equations here. This is prod.
Yeah, we need those for,
I'm just copying these guys. So I'm just taking what I did. I grab it in my editor, make them flush, go over, remember what I'm doing, go forward to the end of the word, put in dot, dot, delete the end of the line, give me a tab, give me 2 tabs, go back to the next line. Is that 3 times? Okay, so that's good. So now we have prod X. So now we go, I'm splitting the screen. So at the top, I'm saying, looking at what the assignment is. Profits in.
I'm just wondering if people were able to open it in their GAMS and are following along what's happening.
So
I was.
You're okay, it's okay. So this is question 1, maximizing profit for competitive price taking producer of X. Competitive firm where it has L to the alpha is the production function. L is the input labor input, and profits is equal to P times X minus W times L.
So just a real simple optimization.
Real simple optimization. So we say production of X, here I just say X is equal to L star star alpha.
Yep. Okay.
Right?
Yep.
And then
It's L to the alpha.
cost of X is going to be
Just wage times labor, right?
so it's going to be profit. Where's profits go?
What is your cost variable?
I think it's cost equals W times L.
I'm just looking. Okay, so cost is equal to W times L.
Right?
I'm going to depart from his, and I'm going to put in lowercase for parameters, uppercase for variables.
Okay, that's actually a good way to do that.
So if I go up above, I can go to alpha. I'm just going to make these guys all lowercase.
Well, then you know what's a parameter, right?
Yeah, it just makes it better. And I also like to indent things.
So W is going to be level.
So its cost is equal to that. And then I'm going to say, so profits 1 and profits 2, alternative 1 and alternative 2. What were these guys? Alternative.
One of them is NLP, the other one is the complementarity, I think. No?
Exercise 1A. We have two profit equations. So why, variables profit. I don't know what alternative one.
I'm not exactly.
Oh, I know here it says,
One is the NLP formulation and the other is an MCP formulation.
no, it's what it says right here. In profits one, write the profits as revenues minus cost, where instead of X in revenue, use the production function P times. So profits one is P is going to be P times alpha, no, X L to the
L to
alpha
the alpha, yeah. Because you're just subbing in the production function. right?
minus W times L,
That's-
right? So that's the first one.
Yes.
And that says profit, and that says profit is equal to, I have to remember the names here. I'm spending, I apologize for jumping around. I'm looking back and forth. And this guy, it says profit is equal to, in profits two, right, as revenue minus costs, where instead of W times on cost, invert the production function to cost as a function of X.
So price times
So this is going to be P times X
X
Mhm.
minus
C of X. And then C of X is going to be from this expression for production of X. It's going to be it's W
times L.
times X star 1 over alpha,
Oh, I see. Hold on. Yeah.
right?
Yep.
So we have two different forms. One where we just focus on the input and the other we focus on the output. So that's profits one and profits two. And then,
Okay, so you just brought that over, flipped around. Yeah, that makes sense. Okay.
so this is exercise 1A. I'm going to say, okay, so I'm going to say model max profit 1, and that's going to be profits 1. And I guess I can, and that includes prod X, and that's going to include cost X.
Okay.
And then I'm going to have model max profit 2, and that's going to have profits 2, and it's going to have prod X, which will determine the value of L, and cost X, which will determine the value of cost. So there, I'm including those other equations just to generate a model that has X, L, and cost. Those are the three variables.
Okay.
I can throw in the two-side equations. They're just simply, we could just as easily report after the fact, but I'm throwing them in there because I wrote the
I
equations.
see. No.
And now I'm going to say avoid bad function. So I'm going to say avoid bad function calls by initializing within the function and installing bounds. In other words, we're only interested in runs where x dot low, because we're going to have our L dot low is going to be equal to 0. Let's make that 1 e to the minus 5th, and x L dot L is equal to 1. And then we're going to say x, and then for the next equation,
So hold on, wait, what did you do right there?
Yeah.
I put in the lower bound and I put in initial level value.
Okay, so you just basically said, don't go below basically 0, right?
So
Well,
we need to
but if the
always
number,
do
I'm
this.
going to take, it's L star to a fractional number. So GAMS will complain if it's try to do 0 to a fraction.
I see. Okay.
So
That's why you put 1 e to the negative
e to the
5.
minus 5th. But then if I put in 1 e to the minus 5th, I better be careful because GAMS will automatically set the level value to the lower bound if I haven't initialized.
So then that's why you had to come right after and say, but I want the initial value to be 1.
Right.
Okay.
And the same thing, I'm going to do the same thing for x. So x dot low is equal to 1 e to the minus 5th. I'm just guessing that that's a large, small enough, a small, and then x dot L is equal to 1.
Okay.
The key thing, and initializing about the level value. This value is passed to the solver as the starting point. Right? Do I want to say anything else? It's as the modeler, it is the modeler's job, responsibility to install bounds which avoid function evaluations outside the domain of the function. Right? It's your job. So the thing is, if you hand the model to GAMS and it croaks and it says, I can't solve it, it's not his problem. If you haven't given it a good starting point, that's your problem.
I see.
Okay. The starting values for linear variables are less important.
Mm.
So here that's going to be cost in this case. So that, okay.
Yep.
So the linear values doesn't matter because that's not going to affect evaluation. But remember, Jim has those two little slides where it reminds you of what a Newton method is.
Yeah.
Remember, the Newton method goes to the function where you started, and then it looks for a tangent. It does a linear approximation. If we go to something where if we start at 10 to the minus fifth, we go down to 0, it's going to shoot us off to nowhere land in the initial. So it's not going to work very well. So this way we have a better evaluation. So I'm going to say I have max profit 1 and max profit 2. I'm going to say solve a max profit 1 using NLP, maximizing profit. So I created a name. And I'll move this down below. And then I say solve 2 using NLP, maximizing profit.
And that's just solving profits too, right?
Yeah. Now I could keep going, but the thing is, I tend to not I try not to be greedy. So I basically say, okay, let's put an exit after the first one.
Mm-hmm.
So the dollar exit says, okay, stop at that point. So please solve the model to this point.
All right, 1 second.
That's fine.
Okay.
So you get this color coding in epsilon in the editor. We get the color coding here. And if I go over to, because it's reading, it's in .gms file. If I go over to, looking to see what other, I'm getting rid of files that I opened that I don't need. So here's the way it looks. Here's the way it looks if I go into my LaTeX file. That's the way LaTeX works. In other words, the editor color codes. It says, oh, this is a text file. I'm going to keep track of what the backslashes are. So that's when I write LaTeX, I'm writing text. The whole point is that if I use the GAMS code or I'm writing LaTeX, I'm just, all I'm doing is editing text. And so the text editor. So that I was just sharing that the text editor, it knows what we're doing. So here it knows the GAMS. So now if I say Control X, Control E, that says open a window, GAMS exercise Q1.
You're just running it now, right?
I just ran it and I can see I get a solution right off the bat. That gives me a solution. The first one, now I'm going to be greedy. I'm saying, okay, that one seemed to work okay. I'm going to just go back, Alt tab back to the thing, hit an up arrow, says GAMS exercise. I do it a second time. So both those guys are working. If I look at the listing file, so there's my second solution is right there. Profit is 1. I look at var profit, and there is, so I have 2 solutions that have exactly the same values.
Yep, we got it too. Or at least I did. Did you get it?
I'm doing it right now. I decided to exit.
There you go.
Yeah, I did it too.
So the key thing, what was tricky on that one was you had to do this inverting, you had to solve. So one is you're solving in the space of L and the other solving in the space
Well,
of
in profit
X.
too, you're just moving around, right? You're solving for L.
Yeah.
You're subbing that in.
Yeah, and the thing is, notice that the prod X and cost X, those were simply installed just to solve those guys. I could just as easily have done a solution that said cost is equal to W times L.
I see,
Right.
yeah.
So you have to distinguish between what do you need to go in the model because it's part of the model equilibrium, and what do I need to go in the model because I want to get a report variable back.
I see.
Right.
Mhm.
So let's go to the last one.
Yeah, so then we need to solve this using MCP.
Okay, so if I write down the profit
Can I
one,
see your solution window for just a minute? I
Sure.
mean, second, actually, not minute. Okay. Yep. All right, yep, okay. Just wanted to.
so now I have profit one. If I'm going to split the screen. So I go like this, I go back here, I search for profit one. So I'm going to look back. So there's my, what was it? Profits one. So there's my first equation. So the first order condition for one is going to be that P times alpha
Wait, hold
times
on.
L.
Yeah, just that. Yep.
Hold on, do 1B real quick first. Or is this, why is this 1B? Is it the top, go to the top of this GMS file. See, it says model profit max is a complementary problem.
Which
Do
we're
we
doing.
need-
Oh, that's what we're doing?
Yeah.
Okay, sorry, that's my fault.
So complementarity says we just write down first order.
Oh, we gotta write, okay, all right. See, this
Remember
is
the
why we need to
complementarity
do
is we
this.
take, so the way to think about complementarity models is we have a bunch of agents that are optimizing. We write down their optimization problems, we take derivatives, we get their first order conditions and we put them down and solve them all together.
Okay, that is helpful. Super helpful,
That's the
yes.
arbitrage condition, zero profit, market clearance, income
Those
balance.
are the three, yeah.
And so the zero profit is simply a first order condition that says, I want that guy to be maximizing in some sense.
It's under the context. A little bit over.
Well, yeah, I also had the issue that I deleted a bunch of this. Like of the,
So this guy, so now if I'm writing my first order condition times L to the alpha minus one. And this, I want this to be W is equal to that. And that's, I want it to be that that guy has to be less or equal to, the cost of the input has to be greater than or equal to the profit. And so that gives me the first order condition there. And then the other side says the W, the X thing is going to say W times 1 over alpha times X star star 1 over alpha minus 1. That's got to be equal to P.
makes sense.
Right? And then we'll say model MCP 1, and that's going to have FOC 1. And what the heck, why don't we just throw in the rest of the stuff here if we, hey, so MCP 1, if I put in prod X dot, and FOC 1 is an L, so I'll associate that with X, and then cost X dot cost. So now I have a problem that defines, I'm going to let L be determined by the first order condition. I'm going to say, throw in prod X, let it determine X, and throw in cost Y. So this is the MCP model with
Oh, that's
X.
what we were missing. We were missing the first order. Thought we were trying.
That's why I was confused. I also
Yeah.
deleted the bottom of this exercise, which I didn't help. I don't know why I did that. I just wanted to clean up.
So the
my
whole point
page.
is that we can take we could solve this just as easily without putting prod X and cost X in there,
Mhm.
right? We don't need to have those in there because we can compute what is cost and what is you know, what is, if we solve for L, we know we can solve X by just doing a resubstitution. But I'm just demonstrating here that we could also just throw them into the model
Mhm.
and let them be computed along with
Compute it
everything
along
else,
with
right?
it.
So
Okay.
that's, and then MCP2. L and cost. Side constraints.
Switch the FOC, right?
Yeah, so no, but we also know it's going to be a little bit more involved in that. I'm going to say FOC 2
Yeah,
dot X
okay. Oh, because I see.
prod, and then it's going to be prod X dot L and cost X dot cost.
I see, because the equation.
Okay.
No, I thought
Mhm.
completely.
Solve, and I say solve. I'm not sure exactly its capitalization. I try to follow a common capitalization thing. I don't know what it's doing. MCP1 using MCP.
Does it matter where we put the solve? Like, can we write model, MCP1, and then the rest, and then model and MCP2, and then just solve?
Yeah, so just
Okay.
you can do it however you want.
Okay.
It's all this part of GAMS. There's the declarative part and the procedural part. The declarative part is we write down what are the equations, what are the models, we declare what's together. And the procedural start, the solve statement, you think about this is an operation on a database. You say solve, and you're saying, okay, take those model relationships, solve the thing, and stick the level values and the marginals back in for me so I can see the solution. So let's just see how this works. Oops, 2 errors.
Yeah, I got something too. I'm trying to figure out.
Do you have a semicolon after the first model statement?
Oh, yes, that's what
Yeah.
it is.
I ran it.
So I could just as easily,
Wait, hold on, your thing's in the way. I need to see what you just did.
yeah, I wish I could get this guy to go away.
That's not helpful.
Put it at the bottom, like all the way to the.
So now I'm gonna just do one model statement. So I do both, I can do them one, or I could do separate. If I put a semicolon there, I have to say model. Yeah. Okay, so I do those 3.
Did you get it?
Yeah.
Let me see your code real quick.
Yeah.
Oh, and if I could actually I could be ultra greedy here. If I wanted to do it, I could say profit. But, I could say, I could also say profits 1 dot profit.
One.
And I can see here, it doesn't matter which one I use because they, doesn't matter. So if I do this, then I'm going to be greedy. I think I can get the whole thing. So they look exactly the same. Because the whole thing about the MCP is you're going to have an equally number of variables and equations. So if we add equation, add a variable, it doesn't matter. So there I get the profit back as well. Yeah. So they all produce the same thing.
People on the line, do you have any questions? Were you able to do that?
I got a little lost at the end, but I'm gonna have to rewatch the video, I think.
Well, maybe I could, it's good, that's good advice. If I go back, I could probably do this again just to say, we wrote down, so the optimization problem, this is inherently an optimization problem. So this is not, it's kind of the NLP formulation is obvious. Other than, so here we had, you could do the problem, you can think about the problem as a problem in L or a problem in W, right? We could also go down here and say, let's do another model. Let me just say, to be clear here, let's say, let's say, model. So let's just do a couple more just to say demonstrate. Could solve these as single equation models. Optimization just as easily.
Okay, yeah, this is helpful.
And compute, calculate cost and X or L afterwards. So let me just, I'll just do that. I'll say, okay, so it's going to say max profit L, and that's going to be profits 1, because that's the equation that involves only L. And I'm going to say max profit X, and then I'll say that's going to be profits 2. And then I could say solve max profit L using NLP, maximizing profit. And then I could say cost dot L is equal to W times L dot L. X dot L is equal to L dot L to the alpha. And then I could say display profit dot L, L dot L, cost dot L, and X dot L. So now that's the other way. So here we have a model that only involves one variable. So we can solve in terms of one, and then, but then we have the other, rather than adding them as side constraints, we do them as a calculation after the fact. And
Yeah, which is what that.
what that one does.
Okay.
And so I could just as easily say, then I could remove this and I could say solve maximize X. And now this is going to say we have cost X. Let's see. Okay, I'm going to say here, I'm going to say X. So now it's going to be L. It's going to be equal to the star star 1 over alpha. Cost is equal to W times X to the 1 over alpha. And then we can report all three of those guys
I
again.
think you didn't put X in the cost.
Well, I made a mistake.
Yeah,
Are you just flipping it, not doing it in
Yeah.
terms of X? Okay, I see.
So I flick it, I can do it the other way. So I could maximize profit with a single X equation.
this is immensely helpful, by the way.
Yeah, this is what we needed. And
So
by the
it's
way,
like you have the logic that's the model, and then you have the equations. And it's very important in terms of with bigger, for small models, it doesn't matter. You can throw all the reporting in, and that way you can see the reporting assignments as well as the logic. But if you're working with large scale models, yeah, you want to be careful. It's stuff that you can report without doing it. You don't want to put it in because it adds dimensions without giving you much, it's like,
Yeah.
so that's the yeah. So let's just verify this guy. I don't want to give you something that doesn't run. So we'll just say. So there's all those different solves go through in one go. Okay, that's fine. So now we go back to the number 2, and I'm really slow here. I'm not doing very well. Exercise 2.
Oh, okay. hold
No,
on.
I think your speed is good.
That's good. Okay.
Yeah, I also got that feedback too.
Okay. I mean, the whole thing is getting comfortable with this process of moving one to the other. And I apologize that I'm not using. There was a few years ago, I had this agonizing that I need to demonstrate to students how to use the GAMS editor, and I tried to do it, and I get mad, and I'm just showing you. This is the box I live in. I've been in this box using this editor, doing this for nearly 40 years, so it's like hard for me to change.
You mean just using Game Studio?
No, but I'm using my editor.
Oh, yeah, I mean, that's not a big deal.
Yeah.
What's wrong with that?
Well, I'm not showing you how to do it with the studio.
Oh, no, this is, I mean, it's the same
No,
thing,
I
it's just
just think
different
that going
colors.
back and forth, like we are following it here when he goes back and forth, but I think over there it is a little bit
The
Oh,
studio is kind of like, you don't have to memorize stuff, because you just know you poke at the right place and it'll give you the listing file where you are. But it's important to bear in mind that we go into one file, we edit it, we run the thing, and then we go into another file to look at the output. And that's just the way it works. And if we want to visualize it, we have to write some code that grabs the stuff in the output file and sticks into whatever we want to visualize with. I'm just going to do the rest of it real quick.
okay.
Should we take a break, maybe like a small break,
So I say 5 minutes.
5 minutes?
Yeah, I'm happy to
Yes.
work.
Do one more maybe
Leave the
before lunch.
Yeah.
Zoom call on.
Does it sound good to DC people?
Sure.
Awesome.
Maybe we could try and figure out this volume, but. Or if somebody had an error, maybe we could.
Okay, it's up to you. I also need to. Here's the-
Oh, not have you sent the code?
Yeah, I dropped it in there and said, just
Ah.
drop this if people want to check what I did.
All right.
But you can put Tom's up there too, because his is obviously much cleaner.
I'll ask him for it.
Yeah,
Everything that he does in this session, I'll ask him for it and I'll post it on notes.
yeah, okay, that works, because I just wanted to get people in now, maybe they want to check over lunch with this. I mean,
Yes.
I definitely am not as like clean and as pretty as
Yeah, but I
him.
think that's a good idea to give it to them now, and
Yeah.
later they can have it with comments and all.
And I ran this and it worked, so.
Yeah. I'm so.
What about we go through the second and then take a break?
Yep, that's what I think. I think we just do one more exercise and then we gotta do lunch.
Okay,
Does that work, Tom?
that's fine. We'll just see if the Vietnamese place is open.
Okay, yeah.
Let's just see here. It's going to be. Oh, it's open. That's good.
All right, so we'll walk over there after.
Yeah, I can order stuff now. Oh, wait, my accepting orders right now. Okay. Next open is Monday, January 31st. So it's not open.
Oh, dude.
Here
That's not right.
we go. So exercise 2A.
Okay.
Model equilibrium as an optimization problem.
So just a real simple. Utility, one consumer, two goods.
Okay. So again, I'm gonna sort of impose my priors on Jim, which is like, when I like to lowercase that, I like to put the value in this way. So if just a fixed value, I like to put it in like that.
Well, yeah, it's good to know you can do it two ways and it will.
Yeah, you can always do an assignment, but it's like, that way it's less stuff. Equation,
What is labor and time? Okay, yeah, it's right there. Okay. Excellent.
Why don't you lowercase the equations as well?
Oh, yeah, equations are lowercase as well. Okay, and then we've got P1 is the price of X. So there's the definitions of these guys, so that's fine. And there's welfare. Okay, so now if I go here, we're going to say the equations, in the first version of the thing, equations was utility and market, supply and demand for labor. So I have to go utility dot U is equal to. So this guy, and here's the utilities right down here. So I'm going to just convert this to be uppercase, lowercase, space, uppercase, lowercase. There's this guy. I'm going to say then, I'm going to say market labor. And that's going to be L bar. That's got to be greater than or equal to X1 divided by beta 1 plus X2 divided by beta 2. So I've converted the outputs into labor demands by dividing by the labor coefficient. And then again, insert bounds, avoid bad function calls. X1 dot L low is equal to 1 e to the minus fifth. And provide starting point for the variables which enter nonlinear expressions. That's going to be x1 dot L is equal to 1, x2 dot L is equal to 1. And we're going to say, and then we have to say model. What do you call it? I think it's the name of the model.
There's just initials and lower bounds. Okay, that makes sense.
Model optimize. And that will be what we got here. We've got utility and MKTL. MKTL, solve, optimize using NLP, maximizing U.
What? Okay, I was going to ask why did you call it that, but I see. Just type it.
And then I'll just see if I can get that far.
Do you have to write maximizing or can you just write max?
I think you can write max. I did it before it worked.
Yeah, I don't know. It's generally it's like there's all this stuff.
Huh?
I like tightly scripted languages where there's a way to do it and you've got to do it that way, whereas GAMS has got all this stuff. He wrote it for World Bank economists, which we don't like to be told this is the way you have to do it. So there has all sorts of shortcuts that are kind of annoying.
Well,
Exercise.
the one thing though, like that helps for me is like,
Let's see if I was able to get this right. Say this. Yeah, I did too. Say that. Maybe we should also explain this to people on the other.
well, I don't actually know how to fix it. That's the issue.
So mine did work.
Okay, hold on one second, because we're having not coding issues, but stupid GAMS
Saving.
issues.
Yeah.
And my little trick didn't work.
Okay, now I was able to get it, but I have an
And
error.
the thing is, he put in positive rather than non-negative early on because there was a maximum of 8 characters in a keyword. Whereas now they've relaxed that constraint and they permit non-negative. Positive drives me nuts because it's really not positive. It's really not negative.
Oh, yeah, I see what you mean.
It's not,
Because zero is included, right?
yeah, it's like, no.
I can't get this.
I got an error.
You got an error, okay. Well, I can't even run it, so.
What is my error? It says symbol declared, but no values have been assigned. Check for missing data. So,
Yeah, I'll take a look at yours, 'cause I can't, my thing.
oh, you know what? I actually need to do this and open a new one and run it.
That's what I tried to do.
Yeah. Size to open this, and I'm now done. Yeah, I still have an error.
Tom, can I see your list file?
Oh, it says here it's in 65. Welfare equals, but I don't want to go that far.
Yeah, we just do an exit.
Oh, 1 second. This didn't get this didn't get my other things.
I got you.
So that time we didn't start at the starting point, you had to solve. I didn't know this was going to be 5, but 1 is good. 1 is always a good place to start.
Yeah. By the way, there are questions in the chat? Because there's chat popping up or no?
13, wow, lots.
Oh, no, that's just Natalie, but I dumped mine in there. Does it work? Right, shorthanded, but you're gonna share your code?
Yeah, sure.
Oh, okay, so Tom's is gonna be much cleaner than mine.
That's fun.
But I
The
just.
great thing about GAMS is kind of like, how much work do you want to do to make it be clean and
Look
pretty,
pretty.
right?
Well, when I'm just trying to get this thing to work.
Yeah.
I can go back and clean it up. It's just,
There's this trade-off, always this trade-off that I tend to be, if you tend to be ultra organized, then it sort of reminds me a little bit of like in graduate school, when I would go to lectures, I had one book that was my first draft lecture notes for classes that were serious, that were
Yeah.
important. I had my spiral notebook with my first round draft, and then I had a second notebook, and I always recopy everything across. So I can be kind of OCD if I'm really trying to do something.
yeah.
And that's the way, if I'm trying to do something, a GAMS code carefully, I'm ultra careful to make sure everything's lined up. So it's very easy to see exactly what it is.
So,
Oh, I don't have, okay.
Complimentary problem, then go get lunch.
That's fine. Walk over. I wonder if the creamery is open. This place over here.
Can I see your model solve thingy? Model optimize utility. Yeah. 1, right?
Oh, yeah, you did, it's MKTL.
Oh,
You have an R in there.
okay, typo.
Yeah, that's usually,
Okay.
that's actually a good thing. It's a typo. Yeah.
MKT1, okay.
Should work.
So Babcock Dairy Store is open. We could just walk over there.
Okay.
It's not that cold today, so.
Yeah, that's.
Yeah, to know. See. Okay, so utility. Zero equals to x1 half of x2. X1.
Oh, you have a semicolon. You don't need semicolon.
Where?
Right after. It's these little teeny things. Yeah, I'll run it. It'll run now.
No.
Oh, really?
Should be able to navigate to the error. Isn't there a thing you can click on?
Yeah, like highlights it in red, but it's always something.
Unknown symbol.
So you have used a name there, a symbol that doesn't exist.
I think it was just
Before you
one,
use a symbol, you need to declare it.
MKTL I have. Okay, let's see.
Oh,
Okay, I
there you
got
go. It was,
It
yeah,
was just, yeah.
okay, let's
um,
do this next part. Declare and solve the complementary problem. And then
That's right.
in
That's right.
famous language, declare victory for now.
So let's solve the complementary problem first. So price of X, of X1. So zero profit 1. So it's going to be 0P1. Let's do all these guys in lowercase. So just let variables be uppercase. 0P2. Market X1. Market X2. So this is going to be, and we're going to, he said at the top, he's going to let the price of, so it says here, it's going to be the modeling. Let L be numeraire with the price equal to 1. So therefore, income is equal to L bar. So it's going to be, and this is going to be a Cobb-Douglas function. So this is going to be market for X says X1. X1 is going to be equal to L bar. Alpha times L bar divided by P1, Cobb-Douglas, X2 is equal to 1 minus alpha, L bar divided by P2, zero profit for 1. So in P2, let's see, where P2, so it says that 1 times what's the input is going to be what was beta? It's going to be beta. So beta times beta 1 has got to be greater than or equal to P1. And it says beta 2 greater than or equal to P2. Because the cost, if the wage rate is 1, beta 1 is how much labor you use per unit output of good 1.
Mhm.
So 1 times beta 1, that's the labor cost, and that has to be greater than or equal to P1. And 1 times beta 2 is greater than or equal to P2, and then this gives us a problem, and then we say model equilibrium. So it's going to be 0 P1 dot X1, 0 P2 dot X2, market X1 dot P1, market X2 dot P2. And initialize, so again, it's assign the lower bounds to avoid bad function calls. So here, in this case, in this model, X1 and X2 are linear variables, are linear models, and they have a lower bound of 0. Right? So in other words, in the nonlinear programming model where we had X1 and X2 going into the objective function, we had to be careful, but here the domain, they don't, X dot low is equal to 0, X2 dot low equal to 0. And we're going to say P1 dot low is equal to 1 e to the minus 5th, P2 dot low equal to 1 e to the minus 5th. And now assign initial values. For the variables which enter nonlinear expressions. Right, so it's going to be, if I look at what I got that's nonlinear, it's not, the first two equations are strictly linear, but the last one is nonlinear. So that's P1 and P2 both.
We'd have initials.
And it's going to be P1 So P1.L is equal to 1 and P2.L is 1. Solve equilibrium using MCP. Right? So there's the there are the variables. There are the equations. It's declared, there are the equations defined, there is the model declared it's an equilibrium problem, associated equations with variables, and there's the solve statement. There's my command line. And there it's solved.
That's your list.
And there's the listing file.